So this is the sixth video on friction. In this video also I'll take up a numerical problem of kinetic friction. Only one problem, okay? There will be three parts of this question. Fine. First I'll write down the question, okay? Question is this. Consider the diagram shown below in which all the details are given. Consider the diagram shown below in which all the details are given. Okay. See, this is the horizontal direction. This is a fixed rough inclined plane. This makes an angle of alpha with the horizontal. This is a fixed rough inclined plane. O is some point on the inclined plane. A small block of mass m is placed here. Now friction coefficient between the block and the incline depends on distance x along O, along this direction. Friction coefficient at a point on the inclined plane at a distance x from point 2 is mu is equal to kx, where k is a positive constant, okay? This means that the friction coefficient between the block and the inclined plane is not a constant value. It depends linearly on distance x from the point 2 as mu equal to kx, where k is a positive constant, okay? Now a block of mass m is released from rest from this point. Okay, this block of mass m is released from rest from point 2. Okay, now it begins to move down the incline. Alright, so three things we have to find out. First, what is the total distance L moved by the block along the inclined plane before it comes to rest? Okay, what is the distance moved by the block over the inclined plane so that before it comes to rest. Before it comes to what? Rest. Second is this. In fact, there are four parts of the question, not three, four parts. What is the second part? Second part is this. At what value of x the speed v of the block is maximum? Third, what is the maximum speed of block in course of its motion? What is the maximum speed of block in course of its motion? And fourth point, what is the time of journey of the block particle? What is the time of journey of the block? These are the four parts of this question, okay? I'll solve each of them one by one, okay? Now I rub this, okay? So solution is something like this. See, I release the block from rest from this point. It begins to move down. At some instant t, the block has come here, it has moved a distance x down the incline. At that point, it has a speed v. Okay. Now what I do, I draw the free body of this block at this arbitrary instant while it is moving down the incline. It has not yet come to rest. Okay. mg, n, and friction will act up the incline, opposite to the direction of relative slip. Since the block is slipping over the incline, so F will be written as mu times n. Okay, fine. What I do, I apply Newton's second law to block down the incline. Okay, let's say at this instant. The net force on the block down the incline becomes mg minus F. So net force on the block down the incline is mg sin alpha minus F. That is equals to mass times acceleration A. Now, acceleration A of the block can be written in several ways. One way it is dv by dt, derivative of velocity, or d by dt of dx by dt, because v is equal to just dx by dt, straight line motion. D by dt of dx by dt is nothing but d2x by dt2. This is the first equation. So this is the first equation, sorry, this is the second equation. I substitute this value of A in this equation. So what do we get? mg sin alpha minus F. F will just be equal to mu n. A can be written either as dv by dt or d2x by dt2. I'll just write it as dv by dt. Now, one more thing. This can also be written in the way dv by chain rule. dv by dt can be written as dv by dx into dx by dt. dx by dt is v. So dv by dx into v, that is v dv by dx. So A can also be written in another way, v dv by dx. Okay. So A can be written in three different ways. One is v dv by dx, other is dv by dt, other is d2x by dt2. So A can be expressed in three different ways, you can see. Okay, fine. Now, how do you find n? We apply Newton's second law to block in direction normal to incline. What do I write? N minus mg cos alpha is equals to mass times acceleration of block with respect to ground in this direction, which is simply a cos 90 degree. Now cos 90 degree is known to be 0. This is 0. So n minus mg cos alpha is 0. So n becomes mg into cos alpha. This is the value of n. Okay. N becomes mg cos alpha. I substitute this n here. So what do I get? M times dv by dt, that is same as dv by dt can be written as v dv by dx, as I stated just now, chain rule of calculus. mv dv by dx, okay. Alright. That is equal to mg sin alpha minus mu mg cos alpha. Mu is how much? Kx. And n is how much? N is equal to mg cos alpha. Okay, fine, alright. So from this what do we get? Now m goes away. So v dv by dx is equal to how much? G sin alpha minus kx into g into cos alpha. Okay, fine. Now we have to find four things. First we have to find what value of x v is maximum. What is the maximum value of v? Also what distance does it move before coming to rest? And what time does it take for the entire journey? Okay. So now we have, what I do first, I first find the total distance which the block moves before coming to rest. So suppose the block moves the distance L before coming to rest. So I shift dx to both sides, that side. So I get what? v dv is equal to g sin alpha into dx minus kg cos alpha into x dx. Okay, fine. Now this I integrate. Suppose first I don't integrate for over total distance, for arbitrary distance. Suppose in time 0 to small t it has covered a distance x. and at time 0 speed was 0, at distance x covered velocity becomes v. Okay, I rub this one. Now integrate this equation. So integrating and inserting limits v square by 2, g sin alpha is constant, it comes outside the integral. G sin alpha into x, kg cos alpha is constant, comes outside the integral. Kg cos alpha x dx 0 to x becomes x square by 2. This is a v as a function of x. Now see, 4 things we are asked to find out. Okay, it is not necessary that you maintain the sequence. You can solve the problem any sequence you want. Okay, 4 questions there are. No? This question has 4 different subparts. You can find any subpart before the sequence need not be maintained. You can find any subpart, any sequence. Okay. So suppose the block covers a distance L before coming to rest. So suppose the block covers a distance L before coming to rest. So in this equation, when x is equal to L, v becomes 0. Rest means velocity v0. 0 is equal to g sin alpha into L minus kg cos alpha into L square by 2. Now 1L goes away. G also goes away. So L becomes 2 by k in tan alpha. This is the answer to one of the parts of the question. Okay. So total distance L covered by the block before coming to rest is how much? L be 1g goes away. L also goes away. So L becomes 2 by k sin alpha by cos alpha. 2 by k tan alpha. One answer has been obtained. Alright. Now I rub this one. Now the question is, at what value of x v is maximum? So I'll again rewrite that Newton's second law equation which I wrote just now. M dv by dt is equal to mg sin alpha minus kx mg cos alpha. Now see, when v is maximum, by the rule of calculus dv by dt is 0. So when v is maximum, implying from the rule of calculus dv by dt is 0. So this term becomes 0. That is same as mg sin alpha minus kxg m cos alpha. Now mg goes away. So x becomes 1 by k sin alpha by cos alpha. It becomes 1 by k tan alpha. At this value of x, v is maximum. This is also another part of answer of this question. Now we have been also asked to find out the maximum value of speed v. So to find the maximum value of v, x is this, at this x, v is maximum. So in this expression, if we replace x by 1 by k tan alpha, we get the maximum value of v. So let v be the v max with the maximum value of v. V max square is just equal to g sin alpha into x. X is 1 by k tan alpha minus kg by 2 into cos alpha into x square. That is simply 1 by k square tan square alpha. Is it alright? Fine. So now you can simplify this term. So this can be simplified. G by k sin alpha tan alpha minus 1k goes away, g by 2k cos alpha into tan alpha. We can write it this way. Tan square alpha is tan alpha into tan alpha. Fine. Adopt this one. One answer we have already obtained. Okay. So what do we get here? We get V max square by 2. This becomes G by K sin alpha tan alpha minus G by 2K. Now see, cos alpha and tan alpha is simply sin alpha from trigonometry. So this becomes sin alpha into tan alpha. This becomes G by 2K into sin alpha into tan alpha. V max square by 2. 2 goes away. V max becomes root under G by K sin alpha into tan alpha is the answer to another part of the question. Okay. Finally, we have been asked to find out one more thing. What is that? After what time the block permanently comes to rest? That is the question. I rub this one, okay? After what time the block permanently comes to rest? Now see, one way of doing is this. We write V as dx by dt and integrate the differential equation. But that is very lengthy. I hope you understand what I am saying. We have been asked to find out after what is the total time of journey of the block. When it starts from rest and again it comes to rest. So one way is this. We have already obtained V as a function of x. So I solve this V in terms of x and then write V as dx by dt and then integrate the equation. That becomes very lengthy. There is an easier way of finding the time taken. See, original equation this I wrote just now here, no? I'll write it again here. This is the equation of motion at arbitrary instant t after it has been released from rest. So this becomes mg sin alpha minus kmgx cos alpha. Alright. So m goes away. Now this we can written as d by dt of v can be written as dx by dt. That becomes g sin alpha minus kxg into cos alpha. This becomes d2x by dt2 plus kg cos alpha into x is equal to g sin alpha. So this kg cos alpha is a positive quantity. It's a positive real number. So this entire thing can be denoted by omega square say. It can be denoted by omega square say. Alright. So this I rub it. So this equation becomes d2x by dt2 plus omega square x barabar capital A, which is g sin alpha constant. G sin alpha, which is c. Let us call it c, say constant. Say c is the g sin alpha is constant denoted by c, which is a constant quantity. Okay. Now see, this differential equation is a second order differential equation. Second order linear differential equation with t as the independent variable, x is the dependent variable. So you must know that the solution of this differential equation is very important. Solution of such types of problems are frequently being asked in J Advanced. For example, 2024, 2023, they are asking such questions. So you must definitely know the solution of this, general solution of this differential equation. General solution of this differential equation is this. X equal to a1 cos omega t, this omega square. This quantity is omega, pronounced as omega square, plus a2 sine omega t plus c by omega square, where c is equal to g sin alpha. Now a1 a2 are constants. Okay, a1 a2 are two constants and c you know g sin alpha. Now a1 a2 are two constants. To find these two constants, we need two conditions. At time 0, x was 0. Okay. So at time t equal to 0, x is 0. So in time t equal to 0, I substitute x barabar 0. Cos 0 becomes 1. a1 cos 0 becomes a1. a2 sin 0 becomes 0. Plus c is simply g sin alpha. G sin alpha by omega square. Okay. So A1 becomes how much? A1 becomes how much? Tell me. A1 becomes minus G sin alpha by omega square. Omega square is kg cos alpha. G goes away. Sin by cos becomes tan minus 1 by k into tan alpha. A1 we have obtained. Now we also need to obtain A2. Now at initial instant the block was at rest. So velocity of block is dx by dt v. At time t equal to 0, v is equal to 0. So we get second condition from there. Now this are a bit, okay? This are a bit. So I differentiate this with respect to time. Dx by dt, that is v. This I differentiate using the chain rule of calculus. Minus a1 omega sine of omega t, a2 omega cos of omega t. Derivative of this becomes 0, constant. At time t equals 0, velocity v is 0. Minus a1 omega sine 0 plus a2 omega cos 0. Okay, fine. Now cos 0 becomes what? 1. Sine 0 becomes 0. This term goes away. Cos 0 becomes 1. So what do we get? A2 omega is 0, but omega is non-zero. So A2 becomes 0. So A2 goes away. Alright, fine. Now rub this one. So x becomes how much? X becomes how much? Tell me. X becomes A1. A1 is how much? Minus 1 by k tan alpha. Minus 1 by k tan alpha. Okay. A2 is 0. That term goes away. Omega square is simply how much? Omega square was A1 sin omega t. Omega square was how much? Omega square was how much? How much was omega? I just let me recall it, okay? What was the right equation? md2, I just write it down, okay? mg sin alpha minus kxg cos alpha. Okay. Okay, fine. So that was omega square was kg cos alpha, okay? I just write down the equation, I forgot it, okay? This will be how much? This will be m d2x by dt2 equal to minus kxg cos alpha. Okay, fine. Okay. Mu mg cos alpha. M also comes here. Okay. So omega square was kg cos alpha. This was omega square. I hope it is clear. Alright, I just forgot that term, so I'll retain it here. Just rough work. Okay. So omega becomes how much? Omega square. So x becomes this much plus how much is x? Okay, c by omega square. And what is c? C is how much? C was g sin alpha. This is omega square. G sin alpha. This c. I'll substitute this here in this equation. So g sin alpha by omega square. I'll just write down the equation. Just give me one time, okay? To c by omega square. C becomes how much? G sin alpha, okay. And omega square is how much? Kg cos alpha. Cos, this becomes cos. Okay, that one, okay, fine. Just check the equation, okay. So A1 becomes, just write the equation one, please give me some time. I'll just rectify it, okay. So from this I get x is equal to c. C is how much? G sin alpha. Omega square is how much? Kg cos alpha. A2 is 0, this term goes away. A1 is minus 1 by k tan alpha. Minus 1 by k tan alpha into cos of omega t. I hope it is fine. Alright. See, g goes away. So x becomes how much? X becomes this much. See, I'll just I'll write it again and I'll write it again. Please give me some time. See, it's not needed. A2 is 0, na? Okay. This term goes away, see. So, what do you write? X becomes A1 cos omega t, A2 is 0. C becomes how much? G sin alpha by omega square. Okay. Now, V is what? Dx by dt. That is V. So, this becomes minus A1 omega sin omega t plus derivative of this becomes 0. So this becomes minus A1 omega sin omega t. Now we have been asked to after what time the block comes to rest. So when the block comes to rest, V becomes 0. That means minus A1 omega sin omega t becomes 0. That means omega t is equal to pi. Because t cannot be 0, no? T has to be non-zero value. So t becomes pi by omega. So omega is what? Omega is equal to root kg cos alpha. Omega is just equal to kg cos alpha. See, okay. So t becomes this much. Pi by omega square is how much? Kg cos alpha. Omega becomes how much? Root kg cos alpha. Kg cos alpha. This is therefore the required answer. Okay. The block will come to rest permanently after this much time, after it starts from rest. So at t equal to pi by root kg cos alpha, the block permanently comes to rest. I hope it is fine. Alright. So the block permanently comes to rest after time t equal to pi by root under kg cos alpha. Pi by root under what? Kg cos alpha. I hope it is clear. Alright. This question also I have discussed, okay. So one thing I'd like to say, see the last part of the question where you have asked to find the time after which the block comes to rest permanently. You must definitely know the solution of this differential equation. It's very important. It's being frequently asked in JEE Advanced 2024, 2023. They are asking questions based on this differential equation. You must definitely know the solution of this general solution of this differential equation. Okay, so you go through it properly. In case you have any doubt, you write it in the comment box. I clarify it. Okay, so I close it here. Fine.